Hi everyone, this video is on mixed exercise 11 question 26. So we want to solve this differential equation, and we can start by moving the x terms to the right and the y terms to the left so that we can use separation of variables. First we can divide both sides by y, which gives us 1 over y on the left hand side dy, and then at the same time we are going to multiply both sides by dx, and also by actually we'll divide by x times x plus 2, which gives us 1 over x times x plus 2, like this. So now we can integrate both sides. So the left hand side is just a simple len integration, but for the right hand side we should be careful, because when we have 1 over x times x plus 2, we need to use partial fractions to integrate this. And we can rewrite this as, so 1 over x times x plus 2 as a over x plus b over x plus 2. And now we can just use partial fractions basically. So we multiply every term by x times x plus 2. That gives us x times x plus 2 is equal to a times x plus 2 plus bx. And actually when we multiply the left hand side we just get 1, so it's just 1 is equal to this. Okay, so now we can set the value of x equal to 0, so that gives us 1 is equal to 2a, which means a is a half. Then we can set the value of x equal to minus 2, so that the first bracket becomes 0, and we'll have minus 2b, which is just minus a half. So therefore we'll have the integral, so here is just 1 over y dy, and then here we'll have 1 over 2x for the first term, and the second term becomes minus 1 over 2 times x plus 2 dx. Now the thing is, we can just take a factor of a half so that this becomes simpler. So it will be a half, and then the integral of 1 over x minus 1 over x plus 2 dx. So at this point we can then integrate both sides. So as I said, the first one is very easy, just len of y, and then for the second term we'll have this half outside, and then 1 over x also integrates to len x, or modulus x. And here is again minus len, but this time modulus x plus 2 plus c. C is the constant of integration. So now that we have this expression, we can also expand the brackets. So it's going to be len y is equal to half len x minus half len x plus 2 plus c. And for the next step, we can basically rewrite this as len modulus y is equal to. Now for here, remember that from the properties of logs, first of all, when we have basically a coefficient, that can be the power, so this is the same as len and then modulus x to the power of half. And also when we have len of something minus len of another thing, we can just write this as a division. So the whole thing becomes len of modulus x over the len of everything basically, modulus x plus 2, and then this power of half, which is also the same as the square root, right? So now for the sake of simplicity here, we can basically rewrite this as, we can also do the e to the power of both sides, so that the e's will cancel, and then we can just write this as y is equal to square root of x over x plus 2. Also we'll also have this constant as well, so here on the numerator it becomes actually kx, because when we do e to the both sides will also have this constant. I forgot to write that here. And then when we have e to the power of c, that just becomes another constant. So that's why it becomes another constant. Right, so at this point, we can just use the boundary conditions. So when x is equal to 2, y is also equal to 2 to find the value of k. So 2 is equal to root 2k over 4. And we can square both sides. 4 is equal to 2k over 4. So k is equal to 8. Therefore, y is equal to root 8x over x plus 2.